Hello everyone, we will start by solving the question 1 Edexcel-GCE 2013 exam. Find the values of the constants A, B, C, D, and E. In order to obtain A, B, C, D, and E, we can use this method to convert this to a form fraction like this. That is, we must have same denominator. Here we have a denominator x squared minus 4, and here we have nothing in the denominator. This means that it is equal 1. In order to have one denominator, we must multiply ax squared by x squared minus 4, and also multiply bx by x squared minus 4, and also multiply c by x squared minus 4, and put one denominator, which is x squared minus 4. Now we do expand, and here we have x4, we write it here. Also we have bx3, so we write here bx3. As for x squared, we have here minus 4ax squared, and here we have plus c x squared, so we write here minus 4a plus c parentheses x squared. And as for x, here we have minus 4bx, and here we have plus dx, so we write minus 4b plus d parentheses x, and we have also plus e minus 4c. Now, as we can see, we have the same form for this fraction. This means that since we have here ax power 4, and here we have 3x power 4, this means that a equal 3. And here we have bx power 3, and here we have minus 2x power 3. This means b equal minus 2. And here we have minus 4a plus c parentheses x squared, and here we have minus 5x squared. This means minus 4a plus c equal minus 5. And here we have minus 4b plus d parentheses x, and here we do not have x. This means that minus 4b plus d equal 0, because here we do not have x. And e minus 4c equal minus 4. Here, if we put the value of a in place of a, which is 3, we can get c in this form. Here, if we put the value of b, which is minus 2, we can get d in this form. And here, if we put c in its value, we can get e in this form. Hello everyone, we will start by solving the question 2 Edexcel-GCE 2013 exam. Given that fx equal ln x, x larger than 0, sketch on separate axes the graphs of y equal fx, y equal absolute value of x, y equal minus fx minus 4. Show on each diagram the point where the graph meets on across the x-axis. In each case, state the equation on the asymptote. As long as sketch tells us, we can specify some points to draw the graph. We start with y equal ln x. We choose an answer for x randomly in order to get the answer for y through the calculator. When x equal 1, y is 0. And when x equal 2, y equal 0.69, and when x equal 4, the y equal 1.39. When x equal 8, y equal 2.07. When x equal 0.5, y equal minus 0.69. And when x equal 0.3, y equal minus 1.2. As we notice here, as if we have a vertical asymptote, when x tends to 0 plus, the answer limit ln x equal minus infinity. This means that we have a vertical asymptote and the equation of this asymptote is x equals 0. Now we connect the points to get the graph. Now we come to y equal absolute value ln x. When x equal 1, y equal 0. When x equal 2, y equal 0.69. When x equal 4, y equal 1.39. When x equal 7, y equal 1.95. When x equal 0.5, y equal 0.69. When x equal 0.3, y equal 1.2. And also we have limit absolute value for ln x when x tends to 0 plus equal plus infinity. This means that x equals 0 vertical asymptote. Now we come to y equal minus ln x minus 4. We do the same thing. We choose points for randomly like this. We also have limit for minus ln x minus 4 when x tends to 4 plus equal plus infinity. This means that x equal 4 vertical asymptote. And now we connect the points together to get the graph. Hello everyone, we will start by solving the question 3 Edexcel-GCE 2013 exam. Given that 2 cosine x plus 50 equal sine x plus 40 degrees. Part A, show without using a calculator that tangent x equal 1 over 3 tangent 40. We must first take advantage of the given. It is found in the given that 2 cosine x plus 50 equal sine x plus 40. Here at the cosine we can use this rule. Also here at the sine we can use this rule. So we have this form which is the same as this. Now we take the cosine x sine 40 before the equal. We also take the minus 2 sine x sine 50 to after the equal. So we have this form. Now we take the cosine x common factor, and also here we take the sine x common factor. Now we divide by cosine x and we have this form. As we know that tangent x equal sine x over cosine x, we can replace the sine x over cosine x to put tangent x. We can also write it in this form. Now we can use this rule. We can conclude sine 40 equal cosine 50. So here in the numerator we replace cosine 50 and put sine 40. And in the denominator, in place of sine 50, we put cosine 40. Now we have here 2 sine 40 minus sine 40, so equal 1 sine 40. We also here in the denominator have cosine 40 plus 2 cosine 40, so equal 3 cosine 40. And we get the answer like this. We now move to part B. Hence solve for theta between 0 and 36 degrees. 2 cosine 2 theta plus 50 degrees equal sine 2 theta plus 40 degrees. Giving your answers to one decimal place. We have in part A 2 cosine x plus 50 equal sine x plus 40. So we conclude from this that tangent x equal 1 over 3 tangent 40. And here in part B we have 2 cosine 2 theta plus 50 equal sine 2 theta plus 40. We can also conclude that tangent to theta equal 1 over 3 tangent 40. Now, by using a calculator, we can calculate 1 over 3 tangent 40 and we get an answer 0.2796. Also, by using the calculator, we can get the answer of 2 theta, which is 15.6, meaning that theta equal 15.6 over 2, so equal 7.8. And it meets this condition, meaning that it is between 0 and 360 degrees. But there is something we must do. Since here we have tangent, so we add 180 to 2 theta. In this way, so we get theta equal 97.8, which is also between 0 and 360 degrees. Also again, we add this time 2 times 180, so 2 times 180, so equal 360, and we get theta equal 187.8, and in this number it applies to this condition, so between 0 and 360. And also again we add 3 times 180, so equal 540, and we get that theta equal 277.8, and this number also applies to this condition. And also again we add 4 times 180, so equal 720, and we get that theta equal 367.8, but this does not apply to this condition. This means that we must stop here, and here we have 4 answer to theta. Hello everyone, we will start by solving the question 4 Edexcel-GCE 2013 exam. Part A, using calculus, find the exact coordinates of the turning points of the curve with equation y equal fx. In order to obtain the coordinates of the turning points, we must first obtain the derivative of f. As we see here, we have x squared times e power 2x. We can apply this rule to them to make the derivative. So we have this form. As for minus 16, it becomes 0 because the derivative for any constant number is 0. Here we did some calculation and we have this form. Now in the second step, we write f prime x equal 0. Here we can take the common factor and we have this form. Now when we have this form, this means 50x times e power 2x equal 0, or 1 plus x equal 0. And in this way we obtained x equal 0 or x equal minus 1. We now obtain abscissa. Now we must obtain the ordinate. So in place of the x, we write its value, which is 0, and we obtain the ordinate. Also, in place of x, we write its value, which is minus 1, and we get ordinate. We now move to part B, show that the equation of x equals 0 can be written as x equal plus minus 4 over 5 e power minus x. Fx equals 0, meaning that 25x power 2 times e power 2x minus 16 equals 0. We can now put minus 16 to after the equal, so it becomes plus 16, and in this way we can get x. We now move to part C. The equation of x equals 0 has a root alpha, where alpha equals 0.5 to 1 decimal place. Part C, starting with x0 equals 0.5, use the iteration formula to calculate the value of x1, x2, and x3, giving your answer to 3 decimal places. x1 equal x, 0 plus 1, meaning that n equal 0, and in this way we have obtained x1. x2 equal x, 1 plus 1, meaning that n equal 1, and in this way we have obtained x2. x3 equal x2 plus 1, meaning that n equal 2, and in this way we have obtained x3. We now move to part D. Give an accurate estimate for alpha to 2 decimal places and justify your answer. As we know, the alpha here is the root, meaning that f alpha equal 0 because alpha is root. So f alpha equal 0, meaning that the alpha is present on the x-axis. If we do f 0.485, we will get a negative answer. And if we do f 0.495, we will get positive answer. This is evidence that alpha exists between 0.485 and 0.495, meaning that alpha is approximately equal to 0.49. Hello everyone, we will start by solving the question 5 Edexcel-GCE 2013 exam. Part A, find dx over dy in terms of y. This means that we must find the answer for the derivative. We can use this rule for the derivative, which is this. And also this rule we can use when we have cosine or sine or tangent or any of these things. Here we have n equal 2 and u equal 3y. This means that u prime equal 3 and secant u prime equal secant u times tangent u. This is a rule that must be memorized. Now we put everything at its value to finally get the answer to the derivative. We now move to part B. Hence, show that dy over dx equal 1 over 6x, x minus 1 power 1 over 2. We note that dy over dx is the inverse of dx over dy. We can always make any fraction we have like this, dy over dx equal 1 over dx over dy. Now we put the answer of dx over dy that we have to get this answer. Now in the question, he wants us to write the last answer like this, meaning we must have x in the last answer. We can simply use this given that we have here and replace the secant power 2 3y. We put x, but this is not enough. We must also get rid of tangent 3y. We can use this rule specifically because it links tangent to secant. Through it, we can obtain that tangent 3y equal x minus 1 power half. Now we put the answer to tangent 3y and the answer secant power 2 3y to get the answer. We now move to part C. Find an expression for d power 2y over dx power 2 in terms of x. Give your answer in its simplest form. d power 2y over dx power 2, this means that we must do the derivative again for dy over dx. As we notice here that dy over dx has the form of fraction, and in order to be able to do derivative, we must use this rule for the fraction, which is in this form. Here we have u equal 1. This means that u prime equal 0 because any number is the derivative constant equals 0. And we have v equal 6x times x minus 1 power 1 over 2. In order to be able to make v prime, derivative of v, we must use the special rule for this form. We must use this rule. We can consider that u equals 6x, so u prime equals 6, and for v prime, so we must use this rule because v has this form. And now we put the answer for u, v, u prime and v prime to get the final answer. Hello everyone, we will start by solving the question 6 Edexcel-GCE 2013 exam. Find algebraically the exact solutions to the equations part A, ln 4 minus 2x plus ln 9 minus 3x equal to ln x plus 1. That is, we must get the answer for x on the condition that x must be between minus 1 and 2. In order for us to get x, we must get rid of ln. Here we cannot get rid of ln easily, but we must obtain a certain form. First, here we can use this rule, and here we can use this rule. Now that we have obtained this form, there is one ln before the equal and one ln after the equal. Now we can get rid of ln by using e in this form. Now we do expand and also we do simplify, so we get the quadratic equation. Here we can use the calculator to get the solutions, or we can use the delta in this form. And because the delta is positive, this means that we have two solutions in this form. So we finally get that x1 equal 7 over 5. It satisfies the condition because it is between minus 1 and 2. We also get x equal 5, but this does not satisfy the condition. This means that x equal 5 rejected. We now move to part B. Give your answer to be in the form where a, b, c, and d are integers. We notice that he wants us to get an answer with ln, meaning we must first enter ln in this form. Now we can use this rule and we have this form, and here we can use this rule and we have this form. Now we can take x common factor, and in this way we get the answer. Hello everyone, we will start by solving the question 7 Edexcel-GCE 2013 exam. The function f has domain x between minus 2, 6 and is linear from minus 2, 10 to 2, 0 and from 2, 0 to 6, 4. A sketch of the graph of y equal fx is showing in figure 1. Part A, write down the range of f. When he tells us the range of f, we must look at the y-axis. As we see here, that the graph is between 0 and 10. This means that the range of f is between 0 and 10. We now move to part B. Find ff0. We must always start by obtaining the answer that is inside. In other words, we must first obtain the answer to f0. This is the first step we must take. f0 is when x equals 0. When x equals 0, the answer to f0 is present here. Exactly. But unfortunately, there is no value of f0 here on the graph. This means that we must get the answer through calculation. We must first get the answer to the equation for this line. We can get the equation for this line because we have 2 points on it, which are this point I will call point A, and this point I will call point B. Now, using the rule for the line, which is y equal ax plus b, and a is in this form, all we have to do is first get the a and b. First, we can get the a through this rule. So we get that a equal minus 2.5. Also, we can obtain the answer of b in this way, using any point on this line. I will use the point b, so we obtain that b equal 5. Now we put their value here, and finally we obtain the equation of this line. Now we want an answer to f0. This means in place of x, we must put 0. So we get that f0 equal 5. Now we must get f5. That is, when x equal 5, we must get the answer to y. As we see in the graph, that f5 is here on this line. Unfortunately, there are no numbers here on the y-axis. For this reason, we must get the answer through the calculation method. We must first obtain the equation of this line. We can follow the same procedure that we followed before to obtain the equation for the line is y equal x minus 2. Now in place of x we put 5 to get the final answer, which is 3. We now move to part C. Find g minus 1 x. As we see here, we have gx and we are required to get g minus 1 x. All we have to do is follow these steps. The first step is to place gx, we put y. The second step is to get the answer to x in terms of y. So we get the answer to x in this way. The third step is in place of x we put g minus 1x, and in place of y we put x. So we get the answer very easily. Now we move to part D. Solve the equation gf(x) equals 16. When we have two or more functions, we have the right to take the last function, which is g. We can put it after the equal, but we must put minus 1 above it in this way. Now we can get the answer to g minus 1, 16 in this way. So we have that fx equal 4. If we come to the graph to search for fx equal 4, we will see that there are two answers here on this line and here on this line. So we get the first answer, x equals 6, and also here in place of y we put 4, so we can conclude that x equal 0.4. So x equals 6 and x equal 0.4. Hello everyone, we will start by solving the question 8 Edexcel-GCE 2013 exam. Part A, express 24 sine theta plus 7 cosine theta in the form r cosine theta minus alpha, where r and alpha are constants and where r larger than 0 and alpha between 0 and 90 degrees, giving the value of alpha to 2 decimal places. Here we can use this rule. As we notice here, this is similar to this, but we can consider that 24 is r sine alpha, 7 equal r cosine alpha. So we have that sine alpha equal 24 over r and cosine alpha equal 7 over r. In this form, we can obtain alpha because tangent alpha equals sine alpha over cosine alpha. And in this form, we can obtain alpha. Also, we can obtain the answer to r in this form. R sine alpha square plus r cosine alpha square equal r square times sine square alpha plus r square cosine square alpha. And here we take the common factor, r square. And because sine square alpha plus cosine square alpha equal 1, this is rule. And we get equal r square. Also, r sine square alpha plus r cosine square alpha equal 24 square plus 7 square. Here we put everything at its value. So we have that r square equal 24 square plus 7 square. And in this way, we get that r equal 25. We now move to part B. Given that theta varies, find the minimum value of v. As we see that v is in the form fraction, in order to obtain the minimum value of v, we must obtain the largest number in the denominator, which is 24 sine theta plus 7 cosine theta. Because the larger the denominator, the smaller the results becomes. We can benefit from part A. It is 24 sine theta plus 7 cosine theta equal r cosine theta minus alpha, which is 25 cosine theta minus alpha. We know that the largest possible number we can get the cosine is 1. So we must put 1 in place of the cosine because we want to get a larger number in denominator. A number in the denominator. So the answer in the denominator becomes 25. And in this way, we get the answer of for V, which is 0.84. We now move to part C. Given that Kate's speed has the value found in part B, find the distance AB. As we can see, here we have a right triangle. For this reason, we can use this rule, which is sine theta equals 7 over AB. We want the answer to AB. So we can write in this form, AB equals 7 over sine theta. But we have a small problem, which is that we do not have the answer to theta. But as we see in the question, that given that Kate's speed has the value found in part B, we can benefit from part B because cosine theta minus alpha equal 1 in part B. And when cosine equal 1, this means that angle equal 0. This is rule. Or we can use the calculator. So the angle equals 0. The angle is theta minus alpha equals 0. This means that theta equal alpha. And we put here the value of alpha and we get the final answer. We now move to part D. Given instead the Kate's speed is 1.68. Find the two possible values of the angle theta, giving that theta between 0 and 150 degrees. As long as we have the answer for speed, we can take advantage of that and use this and put the answer for V, which is 1.68, and also put the answer for R, which is value obtained before, R equal 25. So we get that cosine theta minus alpha equals 0.5. Using the calculator, we get that theta minus alpha equal 60 or equal minus 60. In this way, we obtain the answer for theta, and also the answer for theta can form to this condition.